In this lesson, we're going to look at how we actually prove triangles congruent. And to prove triangles congruent, we'll be using our 3 triangle congruence conditions, which were introduced in the last lesson. Those are side, 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 abbreviated SSS, side, angle, side, abbreviated SAS, and angle, side, angle, abbreviated ASA. Excuse me. We're not going to review what these are right now. If you want to review these again, SSS, SAS, ASA, you can go back and look at the previous video lesson. Before we do our first proof, I want to tell you a word about how we're going to format our proofs. Traditionally, in a geometry textbook, the way that they lay out their proofs is they have this sort of table where they have statements that they know are true, and then on the right hand side, reasons why they know they're true. So you might have something like, I know segment AB is congruent to segment CB because that's a given piece of information that the problem told me. Our format is we're not going to draw this table. We're going to draw a box with the statements inside, and then underneath the box we'll have the reasons. This is partially for compactness. We don't have to draw the table, but mainly because what this will do is we'll be able to add to this lines making connections, showing the flow of the logic. So we'll be able to say, well, because I know this, now I can conclude something. Because I know this, now I can conclude something. Whereas that would be impractical over here to some, I guess we could draw lines and things like that, but the sort of flow chart format for the proofs makes it very straightforward to make these to show and demonstrate these logical connections. Both of these are artificial formats for proofs. In mathematical articles, you don't see anything that looks like this or anything like this. Mathematicians write in paragraphs with diagrams and equations and things like that. They don't use this, but this is for learning how triangle congruence works, and it forces you to make sure you include all the necessary information. So it's a learning tool. So let's look at a couple of proofs, what they look like. Here's our first one. So our proofs, you'll have 3 things. You'll have a given statement, which is information that you are given. I can do this one first. Information that you're given about the diagram. So here we are given x is the midpoint of WZ, and we're given angle W is congruent to angle Z. And then you have a statement of what you're trying to prove. This is your goal. When you get to this statement, you're finished the problem. So here we're trying to prove the 2 triangles in this picture are congruent. Triangle VXW and triangle YXZ. VXW, YXZ. And you also will have a picture. Sometimes you will have problems later on where you have to draw your own picture. But for these beginning ones, this is going to be the format. This is information that you know. It is given to you. This is what you want to prove. So the first step after you've read the problem is to take this information that's in the givens and to excuse me, mark it in the diagram so that you can see the relationships in the information in the diagram. So for example, if I have angle W congruent to angle Z, what I do is I put a little arc near the corner of the angle. This represents that how much turn these angles have, and then I like to put a little what's called a tick mark on them. The fact that the number of tick marks here and here match tells me that this angle is congruent to this angle. If this were an algebra class, or if we had to do algebra, we might say mark them with a variable. We might say A, and then the other one we would also use the letter A to indicate that they had the same measurement. But this is how it's traditionally done with arcs and tick marks. And since we're not going to be doing algebra here, we're not going to be adding or subtracting the measurements of the angles. The tick marks are what we're going to use. There'll be occasional problems where we have to do this where we do want to do algebra, but those are pretty rare. What about this first statement? X is the midpoint of WZ. Well, midpoint means the point in the middle. Here's segment WZ. Since X is right in the middle, that means from here to here, W to X is the same as from Z to X. So that means I know that this segment is congruent to this. So again, I will use tick marks. A single tick mark and a single tick mark will suffice. It's impossible for angles and sides to be congruent. So I have Wx is congruent to xz. So here are my givens that I've been told, and here's what I want to prove. Triangle VXW is congruent to triangle YXC. I want to prove these two triangles congruent. It looks as though we don't have enough information, and here's why. All three triangle congruence conditions, SSS, SAS, ASA, require 3 pairs of congruences. This requires 3 pairs of sides. Each of these letters is a pair. This requires 3 pairs of sides being congruent. This requires 2 sides and the angle in between. This requires 2 angles and the side in between to be congruent. And we don't have 3 pairs of information here. We only have 2. There's our first pair. This angle is congruent to this angle. And here's our second pair. That angle is congruent to that angle. So that means we need some other reason for a pair of sides or a pair of angles to be congruent. And one that we're going to see an awful lot, and we prove that this works in the reading, is what are called vertical angles. If you recall from the reading, vertical angles are the angles that are across each other from each other that are made when 2 lines meet. So here I have 2 pairs of vertical angles. Here's one pair right there, and here's the second pair right there. I use double arcs to indicate those. And we proved in the reading that vertical angles, angles that are across from each other when 2 lines cross in this X shape, these vertical angles must be congruent. And so we should keep an eye open for those. Here I have this same X shape, and so the angles that are across from each other, those 2 and these 2, must be congruent. Now these are the pair I want because those are the pair that are actually part of the triangles. So that means even though it's not listed in the givens, I can say that these 2 must be congruent. And now I'm going to use 2 tick marks because they are vertical angles. So adding this to my diagram, now I can see I have 3 pairs of information, and I'm going to see which of these congruence patterns I formed here. And I have formed this congruence pattern. This congruence condition has been formed. I have 2 angles congruent. There's one pair. There's the second pair. And then the side that touches the 2 angles, that's why the S is between the 2 A's. The side that touches these 2 angles and the side that touches these 2 angles are congruent as well. That's the ASA pattern. You have this angle, side, angle going around the triangle, and then you have the corresponding same angle, side angle over here. This pattern of information between 2 triangles guarantees the triangles must be congruent, which is what we're trying to prove. So in some sense, we're finished with the proof. We know why these triangles are congruent. Now we just have to write it down so that I can see that you know why they're congruent. So let's look at the format. So we're going to have statement in a box, and then the reason underneath. So we're going to assemble our angle, side, angle information in 3 boxes side by side. So my first pair of angles is angle W and angle Z. So I have angle W is congruent to angle Z. I close that box. And the reason I know that goes underneath. The reason I know those are congruent is because this is a given piece of information. My pair of sides is this pair with these tick marks. I'm taking this tick mark information here and here and writing it in the box. So I have WX is congruent to ZX. Little segment marks on top of them. Put a box around it. Now here, technically I can't write given because this does not appear in the list of givens. What appears, how did we know this then? What is in the givens that tells us this? What tells us is this statement right here. And as far as I'm concerned, you can write the most important word in this sentence underneath this box as your reason why you know these are congruent. That will be enough to me to demonstrate that you know where this information came from. So the most important word in this sentence is the word midpoint. That's what tells you these segments are congruent. So I'm just going to write midpoint underneath here. In a more strict course, I would have you write, the given up above here, and then this would follow, but it's not necessary. If this convinces me that you understand how you know these two segments are the same. Finally, our last pair. Remember, we're doing the angle, side, angle pattern in these three boxes. The last pair of these two angles in here. So I have angle WXV is congruent to angle YXZ. And how do I know those are congruent? Because they are vertical angles. And we proved that vertical angles must be congruent. So, I've assembled my angle, side, angle information. This is the necessary information that fulfills this condition. This condition requires a pair of congruent angles, a second pair of congruent angles, and the pair of sides touching those two angles to be congruent. This is exactly what we need. So that means because I know this, and this, and this, I have these lines here showing the reader that I am making a deduction. I'm using my deductive logic. Because I know this, and I know this, and I know this, these three things together form this pattern. And so I can say the two triangles, triangle VXW and triangle YXZ, must be congruent. Underneath this box, we write the congruence condition that we were using. So this is going to be A, S, A. And that concludes our proof. That's what we're trying to prove. We're trying to prove that those two triangles are congruent. Let's look at another one. All right, here's our setup again. We have this given information. Here's what we want to prove. Here's the picture. So let's mark our givens so we can see how they relate to each other in the diagram. AB is congruent to CB, so there's segment AB. I'll give it a single tick mark. And there's segment CB. I'll give it a single tick mark. Then I have angle ABD. So that's that angle right there. I'll give it a single tick mark. It's congruent to angle CBD. Right next to it. CBD. So that gets a single tick mark. And I want to prove the two triangles in the picture are congruent. Triangle ABD and triangle CBD. So again, it doesn't appear that I have enough information. I need one of these conditions to appear. And I only have two pairs of information. I have a pair of congruent sides and a pair of congruent angles. There's no vertical angles in this one. Remember, vertical angles are formed when you get a full X shape like this. We don't have that X shape in this picture. Instead, what we have is we have something that's extremely common, and that's that these two triangles, triangle ABD and triangle CBD, they have this side in common. BD is a side of both triangles. It's exactly a side of both triangles. ABD has BD as a side, CBD has BD as a side, and anything is congruent to itself. A video we watched referred to this as the reflexive property, but that's, if you want to use fancy math words, we can use that, but I'm not going to use that. You're welcome to say reflexive property. Notice I put two tick marks on this. This is because I don't know that it's congruent to either one of these. I'm just double ticking marking to say, well, it's congruent to itself, and also it helps me see the congruence pattern that's forming here. Here I have two pairs of sides, or I have a pair of sides. I have the same side, sort of a pair with itself, and then I have the angle in between these two sides and the angle in between those two sides. This is the SAS pattern. The A is touching both S's, and here the angle, literally the arc for the angle, touches the two sides in both triangles. So I have my SAS pattern. Now I just have to write it up. So first pair of sides, let's say AB is congruent to CB. How do I know that's true? That's a quote from the given. So it's a direct quote from the given. I can write given. Second, my pair of angles, that's these two right here. It's exactly that quote from the given. So I just recopy it down here. Angle ABD is congruent to angle CBD. Also given. Then finally, my last pair of sides is BD with itself. And so I just write BD is congruent to BD. You have to write this congruence, even though it seems ridiculous, because you have to show all three pairs for your side angle side pattern, even if one of the pairs is something with itself. You're demonstrating you understand this triangle congruence condition to me. Pair of sides, pair of angles, pair of sides. The technical name for this is the reflexive property. So you could write reflexive. Or if you don't want to remember that, you can just write same segment. The reflexive property is the fancy name mathematicians give to say that anything is congruent to itself. If you are welcome to use it, you can just write same segment, because it's the same segment. BD is congruent to itself, obviously. So here I have pair of sides, pair of angles, pair of sides. The angle's in the right position. It touches the two sides, just like it does in the letter pattern. So I can say, because I know this, here's my deductive logic, and this, and this. All three of those things together allow me to conclude that the two triangles, triangle ABD is congruent to triangle CBD, that the two triangles are congruent. And then remember, underneath this box, you write the abbreviation of the triangle congruence condition you're using. So I understand that you understand what's going on. Every box should have a reason underneath it. So this is how these proofs work. This is how they will look when you do your homework assignments, and what I will expect from quizzes and tests and things like that. Let me make one more quick comment before we conclude this video. I just want you to start thinking about what are some things that we are allowed to assume in a problem, and what are we not allowed to assume? What are we allowed to assume? And what we may not assume? Well, what we are allowed to assume, first of all, we're allowed to assume anything given. If something is stated as a given, then it's not assumption. You're given it, so you're allowed to use that. Second thing you're allowed to assume is linearity. If something looks straight in the picture, you can assume it's a straight line. You don't have to be told A, B, C are all on the line. It would get extraordinarily tedious to have to say in every single proof, this is a straight line, this is a straight line, this is a straight line, this is a straight line. If it looks like I'm intending it to be straight, you may assume that it's straight. I'm not going to deceive you by being, oh, it's almost straight, but it wasn't. No, not doing anything ridiculous like that. Finally, the third thing you're allowed to assume without me having to be told anything is ordering of points. If I draw a picture and B is between A and C, you can assume that that's the order. Don't assume that B is right in the middle. Like A, B, and B, C are exactly the same, so that B is the midpoint. I'm not saying you can assume that. You can simply assume that they appear in this order. So it could be A, B, C, like that, with B off to one side. You may not assume, do not assume without being told in the givens, that angles have specific measures or that lines have specific lengths. So you couldn't assume, for example, that this is a right angle. You can't assume that this is 90 degrees. Even if it looks like it, if you're not given it or you can't prove it, you can't use that fact, even if it appears to be a 90-degree angle. Second thing is you can't assume congruence of angles or sides, even if they look like they're congruent. In this picture, it looks like AD and DC are the same length. If that's not a given, then you can't assume it. You have to prove it or find another path to assemble your side or angle or whatever information it is that you need to assume for the proof. Thank you for listening, and I'll see you soon.